All right, ordering fractions, decimals, and percents. So here is our warm-up. Give it a pause and try this out. Pause now. Okay, so this is how I chose to solve it. So I turned everything into a percent. So to change a fraction into percent, I just do 6 divided by 20. It's going to give me 30. The percents are already as a percent. That's easy. And then 0.9, I just do it times 100, and that'll give me a percent, right? So just divide 6 divided by 20 times 100. And then once I've got all of those, I can set them in place like this. This is a possible answer. It's not the only answer. So I put the smallest number here, the largest number here, the second smallest, largest numbers here, second smallest numbers here. And then after that, it really doesn't matter what order you put the ones in the middle. They're all going to work. So hopefully you got something similar to this. That's wonderful if you did. All right, on to the handout. So we got fraction review here. So to begin, we're looking for, to add or subtract fractions, you need to have a common denominator, as you know, and the easiest one to work with is the lowest common denominator. So when we have something like this, we've got 1/3 plus 2/5. Our lowest common denominator is 15. So to get from 1/3 to something out of 15, I have to multiply by 5, top and bottom. Same thing here. To get from 5 to 15, I have to multiply top and bottom by 3. And then after that, I just add them up. I have 5 plus 6 is 15, gives me 11 out of 15. All right, same thing here. I've got 2/3. I have to multiply 3 by 4 to get 12. And so therefore 2 by 4 to get 8. 4 times 3 gives me 12, and 1 times 3 gives me 3. And that means I now have 3 12ths plus 8 12ths. It's going to give me 11 12ths. So hopefully that was easy peasy squeezy and review. Multiplying fractions, this one's always more difficult. So, well, I think it's the easiest one, but people find it difficult. So no common denominator is necessary. Multiplying fractions is so easy that people forget how easy it is. They think that multiplying fractions should be hard, and so they make it so hard. So here we go. If I got 7 over 8 times 1 over 5, all I do is multiply the numerators. 7 times 1 gives me 7. 8 times 5 gives me 40. 7's a prime number, so I can know I can't reduce. Done. I know, it was so easy. People think fractions are scary, multiplying is scary. This should be scary. It's really not. 4 times 1 gives me 4. 3 times 6 gives me 18. So, and then I have to reduce it to get full marks. So 4 divided by 2 gives me 2, and 18 divided by 2 gives me 9. All right, so what I would like you to do is pause this video here, and there is a video on dividing fractions. I'd like you to give that a watch and then come back and do the back half of the note. Okay, pause now. Okie doke. So I just wanted to give a quick explanation here for anything that you didn't feel like was covered in the video. So why are we multiplying by a reciprocal of the second fraction when we're dividing? And essentially, I'll explain it to you with a picture. So if I have a half and I'm dividing that in 2, so here's my half, and I divide that half by 2. I now have a quarter. And what someone did was they figured out 2 over 1, because anytime you have a whole number, it's over 1. Somebody figured out that if you do this, 1 times 1 is 1, 2 times 2 is 4, magically it lines up. Because while dividing 1/2 in half isn't so difficult, once it gets to bigger numbers, that can get pretty crazy. So if I want to take one of these quarters, I want to divide it by 3. Whoop, whoop. Well, now I've got this itty bitty bit here. And if I finish dividing all the other ones by 3, then I can count. Do. So if I do that, I've now got 1 of 3, 6, 9, 12 pieces, which is the same as if I had done 1/4 times, remember, 3 as a whole number is 3 over 1, 1/3. 1/4 times a third is 1/12. So it's not so much that we're flipping the second number magically or randomly. We're flipping the second number because it conveniently creates a pattern that lines up with what actually happens when I'm taking a quarter and I'm dividing it into 3 pieces. It's just a faster, easier way, so I don't have to draw a picture. And so once you get to high enough numbers, the picture doesn't make sense, right? If I'm wanting to divide this into, 128 pieces, I'm going to be here all day just and then trying to count them all. All right, so back to the back of your handout. So to divide fractions, we take the reciprocal of the second fraction. So that means we're flipping it upside down. A reciprocal is actually the number that you would have to come up with to multiply with another number to get it back to 1. So for example, I'm just going to randomly show because I'm a nerd and I like that. All right, so the reciprocal of 2/3 is 3/2. And the reason we do that is because that is what it takes if I multiply them. 2 times 3 is 6, 3 times 2 is 6, 6 over 6 is 1. Okay, so the reciprocal of 2/3 is just the number I have to multiply 2/3 by to get back to 1. That's all a reciprocal is. So yes, we're flipping it upside down, but we're doing more than that. We're finding the number that would take this first number back to 1, right? So we're finding the other half of it. Okay, that's what we're doing. So here we go. I have 4/5 and 2/3. So I'm going to flip this and I'm going to change it to multiplication, and then it's back to easy peasy multiplication. 4 times 3 is 12. 5 times 2 is 10. And then I have to simplify it. So 12 divided by 2 is 6, and 10 divided by 2 is 5. And 6 over 5 can be simplified to 1 1/5 as we discussed yesterday. Okay. And this one, I've got 1/3 divided by 3/5. Just flip the 3/5 upside down. And I got 1/3 times 3/5. Or 5/3, and that's going to give me 1 times 5 is 5, and 3 times 3 is 9. And I don't have to reduce it because 5 is a prime number. All right, what's this next one? Oh, putting it all together. Okay, so we're going to pause for a minute here, and you're going to try these out, and then I am going to show you the answer. So pause, try it out. Okay, and we're back. I know, it's a lot for a Friday afternoon. Here we go. So, lowest common, actually that's overwhelming. We're going to do this. Lowest common denominator, 15. So if I got 3 and 5, my lowest common denominator is 15. I'm subtracting, so I need that. So I got 1/3 to get it to 15. 3 times 5 is 15, so 1 times 5 is 5. Here, to get this to 15, I need 5 times 3 is 15, so 3 times 3 is 9. And then I've got 2 negatives here. And a reminder that whenever I have a negative, I can write a negative like this, or like this, or out in front like this. So if it's the same as having it out in front, these 2 negatives are going to cancel themselves out, right? So that'll give me plus. So then I got 5 plus 9 gives me 14. Over here, see, I started doing the lowest common denominator. You can see it all whited out here, but then I noticed we're actually multiplying, which is easy peasy. So 2 times 4 is 8, 7 times 3 is 21, and it's a negative, but we don't want that negative on the bottom. So when we're working with a fraction, putting the negative on the bottom is fine. When we're giving an actual answer, what we want it to look like is actually with the negative up top or with it out in front. So just like I said here, all these things mean the same. This is just a politer way of writing this. It's kind of like in English class where you put capitals on the beginning of your sentences because that's just the way we do things. In math, you put your answer up top or in the middle because that's just how we do things. All right? It's our own little math language. Here, it looks like you can just do this one separately from these pieces. You can't. You cannot do a mixed fraction and add, subtract, multiply, or divide with it. You have to turn it into an improper fraction. So 1 times 4 is 4, plus 1 gives me 5 over 4. I'm dividing, so it means I need to flip the second fraction and change this to a multiply. I've got negative 5 times 3 is negative 15. 4 times 2 is 8. And then I got 15 over 8. And if I want to switch that back to a mixed fraction, I can see that that is 1 and 7 over 8. And it's also negative, so be careful with that. All right, and the final question. So this is just chaos down here. This is craziness. So if I start with the multiplication, I end up with 2 times 3. I end up with 2 times 3 is 6, and 5 times 4 is 20. And then over here, I have 1/6 divided by 2/3, so I'm just going to flip that. Next line, I leave this 1/3 alone. I'm just reducing this 6/20 to 3/10 just so I can have an easier time with it. I'm multiplying here. 1 times 3 is 3. 6 times 2 is 12. So now I have 3/12, but I can simplify that to 1/4. Why would I want to do that? Well, so it's easier to figure out my lowest common denominator. So the lowest common denominator between 3 and 4 is 12, but the lowest common denominator between 3, 4, and 10 is actually 60, which is annoying, but that's how it goes. So to get from 3 to 60, I have to multiply by 20. So the top, I multiply by 20. To get from 10 to 60, I have to multiply by 6. So 3 times 6 is 18. And to get from 4 to 60, I have to go by 15. So 1 times 15 is 15. And then I just have 20 plus 18 is 38, minus 15 is 23 over 60. And I know it is fully reduced because 23 is a prime number. Now, there is some practice homework, so I'd like you to work your way through that. Make sure you check your solutions. All right, have a great weekend. Make good choices.